cross multiply, and I would get x squared is equal to what? A times b. Does everyone agree? Then what would I do? Then I would take the square root of x squared and take the square root of ab, correct? Where's the square root of x squared? So x would equal to the square root of what? ab. And this right here is your formula for finding the geometric mean of two numbers a and b. And the geometric mean we're calling what? X, right? So if I ask you to find the geometric mean of 5 and 8, what are you going to do?
Plug them into the strings.
So find the geometric mean of these three. What's the geometric mean of 5 and 8? How am I going to find that? Well, geometric mean x is always equal to what? The square root of what?
AB.
A times b. Well, what is a? So 5 times b, which is? So that equals what? Square root of? Am I done? Need to simplify it. That would be square root of 4 times square root of 10, which is 2 square roots of 10. How am I going to find the geometric mean here? Don't worry, how about this, guys? Look, everybody go through this with me. I'll screenshot it and put it on canvas. Okay? And I'll give you a second to write it down. How am I going to find the geometric mean of 10 and 9? Huh? Square root of what? 10 times 9. So x equals square root of what? 90, which would be square root of 9 times square root of 10, correct? So x is equal to 3 square roots of 10. If they ask for it in a decimal and round to a certain amount, then that's what you do. If they don't, you assume they want it in this form. So I find the geometric mean of these. Square root of square root of 3 times square root of what? 12. Which is the what? Square root of what? Never mind. Never mind, guys. Erase this and make it, I don't know what I was thinking, 3 and 12. How about that? It's my one mistake for the year. From today on. So x is equal to the square root of what? 36. What's x equal to? Geometric mean is 6. Think we can handle that? It is important that you understand what the geometric mean is. Okay? Any questions there? What I want you to remember is this, though, right here. This is important. because this is how we're going to teach this. Now what I want you to do is do your best to draw 3 identical right triangles. Then on each of those right triangles, I want you to draw an altitude from the right angle. So, let's see. I can do that by lining that up because I know that's a right angle. See where I'm drawing the altitude every time. What we're going to talk about is this situation with regards to geometric mean. And if you try to split this up into 3 triangles, it will get very confusing. I actually used to teach it that way, and I have found that this is the best way to do this. And unfortunately, this won't be online. Well, I guess it will, because I'm going to shine. You guys scoot to the left here. Yes. Somebody turn one of those lights off. Because this one I truly think is better taught if I do it on the board. You guys all scoot over in these rows. What we're going to do is we're going to talk about our means and our extremes. Nice forehead. this situation, when you see one like this, you say, okay, that's a geometric mean problem. There's 3 different situations. They're all going to fit into that. Okay? And all is dependent on which one is your geometric mean. So, if you look at our first example, theorem 8-1. Actually, I'm sorry, I don't write it up. This one right here. When this is your geometric mean, okay? The extremes are the 2 parts that the mean created. What parts did this mean create? This is the mean, geometric mean. What parts did it create? Those 2 pieces, didn't it? When the side of the triangle is the geometric mean, your extremes are the part on its side. So which would be the part on its side? This left right here, right? And the whole thing. The part on its side and the whole thing. That makes sense? So when the geometric mean is the side of the triangle here, or the legs, it's the part on its side and the what? The whole thing. Well, guess what? That rule actually works over here too. When that's your geometric mean, what are the extremes? The part on its side, which now is the what? The little part here, and the what? The whole thing, which is B. And all of them fit into what? This proportion right here. So when you have a means and extremes problem, if the mean is the middle one, then the extremes are what? The 2 parts. So if the mean is one of the sides of the triangle, then it's what? The part on its side and what? The whole thing. Side of the triangle, the mean is here. It's the part on what? Its side and what? The whole thing. Okay? Those always fit. That's geometric mean. They always fit into that right there. I'm going to go up to the computer and I'm going to take a screenshot of that. And then I want you guys to have that to look at. And if you want to write down those words that I said for them, you can. Okay. Any questions there? Like I said, I'll post that onto, what's it called, Canvas, yeah. So you have that to look at. Now, let's get out our workbooks and let's have, I want you to leave that paper out with our means and extremes on it. And let's work on some problems. Let's go to page 97. that's hard to read. Let's go down to number 11. I mean, do I need to do any more of these? Find the geometric mean? I think we're good there. And how this all works is basically what you have is you have three similar triangles. Can you see the three similar triangles? And I forgot to put the right angle on our picture, so you might put that on your picture. On all the three of them I had. Okay, what we have to say is define x, y, and z. Here's what I want you guys to say to yourself. What am I going to make my geometric mean? Because isn't that what determines where things go and what, and so on and so on? So what do you guys want to make your geometric mean here? Z. If we were to make z our geometric mean, it's the altitude, right? So go over here. Do that. Where does your, making a proportion, right? So if z's our geometric mean, it goes what? Z goes here, and it goes there. Our geometric mean is the thing that goes on there twice, correct? What then is the extremes? The two parts it creates, right? When it's the middle one, so that would be 3 and what? You're good to go, aren't you? Cross multiply and solve. Z squared is equal to 27. Well, that's 9 square root of 9 times square root of 3, so that's 3 square roots of 3. Correct? Now you know why we went over square roots, huh? Something we're going to use all this chapter. Now, so I found z. Now, let's find, this was to find z. Now let's find x. So that means let's make x our geometric mean. So that means x here, x here. And then what are the extremes for this being the geometric mean? The part on its side, which is 3, and the what? Whole thing, which is 12. Does everybody see that? X is 6. Now to find y. It's the same concept as the one we just did, except y is now our mean. So what are our extremes? The part on what? Its side and the what? So 9 and 12. So y squared is equal to 9 times 12. Huh? 108. Take square root of both. Anybody? 2 times 54, yes, but is 9 the largest perfect square that'll go into that? No, it's not. How about 36? Square root of 36 times 3, so the answer is 6 square roots of 3 for y, right? Everybody write that down, make sure you have it. Now, here's the deal. They don't always have to make, and you guys write that down, but I'm going to put number 14 up here on the board, and I'm going to go up there and do it. I guess I won't zoom in anymore. Tell me when everybody's got that down. All right. Ooh, that's a little close. Let's look at number 14. Well, this does not want to zoom out or zoom in, and I don't know why. There we go. Okay. What's the difference to this one? Sit up, please. Now, on the other one, all three of our unknowns were the three means we're going to use, right? That's not always going to be the case. So sometimes you're going to need to do one earlier. Now, we can set up three proportions. Let's write the three proportions we can write. If we make this our geometric mean.
Alright.
If we make this our geometric mean, what would I have? 5, and then what here? 5. So don't get in the habit of just what? Always making the variable the geometric mean. It's not always going to be the case. Then what are the two extremes then? X and 2, right. Okay, that's one of them. Now, let's make y. So if y is our geometric mean, it's the one that goes up here twice, and what are the two extremes? The one on its side, which is 2, and then the whole thing, which would be what? X plus what? 2. Would you guys agree? The other proportion I could write would be this one, where z is my geometric mean. Now, what are the parts?
X and X plus
At the one on its side, x, and the whole thing, x plus what? 2. Now, the only reason hopefully, when you start doing this, you won't need to write all three of those down like that. You'll kind of see which one you probably need to do first. Which one does it the most good to solve first? I mean, if you want to solve this one, you get x squared plus 2x is equal to z squared. You want to try to solve that?
No.
Do you want to get y squared is equal to 2x plus 4? Probably not going to help you. Which one's only has one unknown? This one right here. So once I solve that, won't it be just easy to plug an x back into those? See, once I find what number that is, then these will be easy to find. I'm not saying when I say show all steps work, yes, you have to write the proportion each time, but you don't have to necessarily do this each time. Okay, you could go in yours and first find x. Solve this, and what would we get? Is equal to what? Divide both sides by? Now, what's going to happen here? 2 over y is equal to y over 14.5. Correct? So what do you get here? 29 is equal to y squared. Then what do you do? Square root of 29? Everybody see that? And that's simplified. So here, this would be what? 12 point, then we said it was 12.5 over z is equal to z over 14.5. Z squared is equal to, what do you get? 12.5 plus 14.5. I don't want to do that in my head. Huh? Correct? Take square root of both sides. Z is equal to, what's the square root of 181.25? You have decimals, finish the decimal. Don't leave that decimal. Square root of 181.25. 13.46192. So on and so on. I'm betting, did they ask us in the directions to round? Okay. I would have both of these sitting here, and then you're It's not so bad, is it? But it is, if you start trying to separate the triangles, it can get really, really confusing. This is the best way I've learned to try to help out and teach this, because like I said, it can get confusing. Your assignment is numbers 1 through 6, 8 through 24. Write problems, draw figures, show all steps of work. Then guys, you just put answers on these. Do in the hour at Wednesday. I was looking up there. I'm gonna write over these, okay? It was hard to see on the video. The video's still rolling. That'll be a little easier to see. Except that I write over it almost doesn't work correctly. Not that any of you actually watched the video.
I watch it.
Did you guys say you actually watch it?
Yeah, I'm going.
I try to watch mine during study hall. I have someone play weird draft videos in my audio.
Alright. Well, it's good to hear.